All right, in this video, I'm going to teach you how to simplify something like this, but also save yourself a great deal of time in doing the process. You might be sitting next to somebody that's going to spend a lot more time than you are once you get into that factoring portion. Let's talk about that, and let's figure out how to do a problem like this. Okay, you've got an exponent over another exponent, so that's power over power rule. It means we need to multiply our exponents together when we're simplifying. So base stays 9, but 3 times 1/5 becomes 3/5. So now what we've done is we've just taken two exponents and broke it down into one. Now we need to take this fractional exponent and write this out in radical form. We should know by now that 3 on top, 5 on bottom, so we got a numerator of 3, denominator of 5. What that means is we take the denominator and put it right outside the root. The 3, which is my numerator, is going to go on the inside, and then my base number goes right there. So we went from fractional exponents to radical form, and now we need to simplify out of this. Now, I know that the fifth root of 9 would not come out to a nice, neat number. There's no number that's an integer that we can multiply by itself 5 times to get 9. So that's going to be a decimal that goes on forever and ever and ever and ever. No sense in simplifying that way. But we could take 9 to the third power and simplify it that way. 9 to the third power is just 9 times itself 3 times, so that 5 is going to stay out there, but 9 to the third power is going to turn into 729. So now that we've got 729 inside the radical, now we need to ask ourselves, does the fifth root of 729 come out nice and neat? And I'll just tell you right now, I've already checked on the calculator, it does not. So because the fifth root of 729 does not come out nice and neat, we need to factor this out and hopefully get a perfect fifth root. I need a number there that does have a value times itself 5 times that we could simplify even further down. So we put your 5s in. We're looking for some number times some number that makes 729, but hopefully this number here or this number here is a perfect fifth root. Now, how do we determine what numbers are perfect fifth roots? It's actually quite simple. I tell my students to make a list over here and say 2 to the 5th power, 3 to the 5th power, 4 to the 5th power, etc. if you feel you need to continue going. Whatever numbers I get here, here, and here, those are the only values that I'm going to divide 729 by. I will see students all the time start taking 729 here at this point, and they're dividing it by 3. There's no sense in dividing it by 3, because if you put 3 in there, right, the fifth root of 3, that's also not going to come out as a nice simplified answer. So that doesn't help us unless that number over there times 3 was a perfect fifth root. So what are our perfect fifth roots? Well, we can figure the 3 of them out right here. That probably are only 3 that we're going to need to check. 2 to the 5th power just means 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 times. 2 times 2 is 4. 2 times 2 is 4. Times 2. 4 times 4 is 16. 16 times 2 is 32. So the first number I'm going to try and divide 729 by would be 32. Then I would go 3 to the 5th power, which is just 3 times itself 5 times. That actually comes out to 243. And then 4 to the 5th power, 4 times itself 3 times. I believe that comes out to 1,024 if I remember correctly. Don't quote me on that, but the fact that it's 1,000 right there, well, I can't take 729 and divide it by 1,000 and hope to get something nice and neat. So that one's off the table. So while the person sitting next to you might be dividing this by 3 and then by 4 and then by 5 and then by 6 and just continually trying these numbers that really aren't going to help them move forward anyways, you're going to look at your list and say 729 needs to either divide nice and neatly with 243 or 32. If it does not, you're done. That would be simplified. But 729 does divide by 243 nice and neatly. What it ends up making is 243 times 3. Those two multiply together to make this. But what's so special about 243 when talking about a fifth root is that the fifth root of 243 is 3. So we are now able to take that right there and turn it into a nice, neat, good-looking 3. So all we got to do to finish this problem out is take this part here, bring it down. 3 5th root 3 would be your final answer when simplifying from this fractional exponent. So again, the list over here, if you end up getting a 5 right there, you need to put all of these values through 2, 3, 4 to the 5th power. But if that was a 6, you need to be doing 2, 3, 4 to the 6th power. If it was a 3 right there, it'd be 2 to the 3rd power, 3 to the 3rd power, 4 to the 3rd power, and that will give you the numbers you should be dividing this value by to get you to your most simplified form. Hopefully this makes sense. Study hard and good luck on your upcoming test.